Hello everyone, welcome to my channel Education for Aspirants. Today I am going to discuss the concept of extendable hashing method for solving the collision inside the hash table. Let's start the session with the concept of extendable hashing. You know guys, in hashing technique, when two or more elements will map into a same address inside the hash table, then that situation is called as collision. So let's move the concept of extendable hashing. In extendable hashing, normally there are two terms we are using, that is directories and buckets. Okay, in bucket we are using two different type of bucket. One is global bucket, second is local bucket. Okay, if you'll see here in the picture, so these are the two buckets we are considering. So the left side bucket, the left side space is called as global bucket, and the right side space is called as local bucket. Okay, so if you see here in the local bucket size, there are two buckets are there, and generally we will store the elements inside the local bucket. Okay, in the global bucket we will store the address, and remember in extendable hashing we will store the address in terms of directories, and we will use the binary digits to represent the directory. The concept says that the global depth is number of bits in the directory ID. How many buckets we are using to store the elements, that is called as local bucket. So here if you will see, these are the pointers we are using to represent the buckets inside the local bucket size, and each directory will point to a particular bucket inside the local bucket size. Then how will you find out how many directories we will use inside the global depth? Clear? Whatever the global depth size, if you will find 2 to the power that global depth, then it will give you number of entries or number of directories we will have inside the global bucket. Clear? Remember, we will use binary digits to represent the entry. Clear? When a local bucket will fill, then at that time we will split the local bucket. That's why the point is local bucket splits when it is full. Similarly, the global bucket will split when the length of the global bucket is less or equal to with the length of the local bucket. Clear? So local bucket will split when the overflow condition will occur in the bucket. Similarly, the global bucket will split whenever length of the global bucket is less or equal with the length of the local bucket. We will discuss this whole concept by using a example. So let's see the example. The question is, insert the keys into the hash table with bucket size 3. Bucket size 3 means local bucket size is 3. Okay, means inside the bucket we can store only 3 elements. First of all, when we will start the processing, at the initial state the length of the global bucket is 1 and length of the local bucket is also 1. If length of the global bucket is 1, then how many entries you can store inside the global bucket? 2 to the power global bucket length. So 2 to the power 1, that equals to 2. Means 2 entries you can store inside the global bucket. Clear? So see here, I store 2 entries. Then you know that always in the global bucket the directories will be represented by using binary format. Okay, and here whatever the directories we will represent, the length of the directory will become 1 because global bucket length is 1. So that's why we will use binary digit with the 1 bit size, means we will represent either that is 0 or that is 1. I hope understood. So that's why in the global bucket I have used 2 directories, one is 0, second is 1. Then so in the local bucket size also we have taken 2 buckets. So one bucket is represented by 0th address and second bucket is represented by 1 address. Clear? Now we will fill up the element. So here though the global bucket size equals to 1, that's why what we will do, whatever the elements it has given, so first of all we need to calculate the binary digit of the element, because we will represent it, because we will handle this, because we will store these elements based upon their binary digit value. Okay, so first of all what we will do, we will find the binary digit of all the elements which are going to store inside the hash table. Okay, and though here the global bucket length equals to 1, that's why from the LSB bit side, we will choose first bit, 1 bit, because the length is 1. So that's why we will choose 1 bit to represent the element. Okay. So see here, if we will consider 1 bit for 16, that is 0. Means if it is 0, it implies that the element 16 will store in the 0th bucket. Clear? What is the 0th bucket? This is 0th bucket. Okay. So that's why I will store that 16 into the 0th bucket. So store here. Next element is 4. First bit is 0. So that's why I put 4 here. The next element is again 0. The LSB bit is 0. Then that element belongs to this binary format is 6. So put 6 here. Next element is 22. Its first LSB bit is 0. Hence it will also store in the 0th bucket. But here 0th bucket, it is overflow condition because there is no free space present in the 0th bucket. Okay. Now what you will do? You need to split to the local bucket. So which bucket you will split? That bucket you will split. Okay. So previously the global length equals to 1 here and this length also 1, right? Previously the length of the local bucket is 1 1 and the global bucket size is also 1. Clear? Now I will split to this bucket. Clear? I should not touch to this second bucket. I should split to the first bucket because overflow happens here, right? Now if I will split it, then 2 new buckets will create. Clear? But is it required to split to the global bucket also? So check here. What is the length of the global bucket size? Global bucket length equals to 1. Similarly, what is the length of the local bucket size? Length of the local bucket is also 1. So as per the rule, so always the global bucket length should be greater from the local bucket length. If the global bucket length is equal with the local bucket length, then we need to split. Clear? So if we split here, now both the global bucket as well as local bucket will split. So see here, I splitted, the global bucket length will become 2, right? The first bucket I splitted, means this length equals to 2 and this length equals to 2. But the second bucket I didn't split, hence the length of this bucket equals to 1 only. Remember, this is main important thing. So this bucket I didn't split. Though the global bucket size equal to 2, so how many entries will be present here? 2 to the power 2. 2 to the power 2 means 4. Clear? So you will store 4 entries inside the global bucket and the length of the entries is 2. So what are the entries should be? 0 0, 0 1, 1 0 and 1 1. Now I will point the entries directories to different buckets in the local bucket size. See here. Now if you observe which bucket we divided, that is 0th bucket we divided, right? So though we have divided to the 0th bucket entries, that's why what you will do, in the first entry where 0 present, so here 1 0 present and second 0 present here, right? So in these 2 cases only 0 present. Then check what is the next bit associated with this. 1 bit is 0 here and second bit is 1 here, right? So 0 bucket divided, that's why 0 bucket divided into 2 buckets. One is 0 0, second is 1 0. Clear? 0 0 will point to this and 1 0 will point to this bucket. Then 1 bucket didn't divide, that's why 0 1 is pointing to this bucket and 1 1 is pointing to this bucket. I hope everybody understood. Now after doing this, you go to the binary digit format of all elements and consider 2 bits to store the element. So if you will consider here the first 2 bit for 16, first 2 bit is 0. So put 16 in the 0th bit. Clear? Then second for 4, that is also 0, means put 4 here. Then for 6, that is the 2 bits are 1 0, right? So put 6 here. Next element is 22. What is the last 2 bit? 1 0. So put 22 in the 1 0 bucket. Clear? For 24, the last 2 digits are 0 0, means put 24 in the 0th bucket. Clear? Then next is 1 0. For 1 0, last two digits are 0 0, but there is no space in 0th bucket now. So what you need to do? Again you need to split. Clear? So if you split here, which bucket will split? the first local bucket you will split, right? So if you will split to the first local bucket, then what is the size of the local bucket here? Local bucket size is 2. Then what is the size of the global bucket? Global bucket is also 2. Means what is the relation of global bucket and local bucket length? That is equal. And you know that if global bucket and local bucket both are equal size, then at the time of splitting to the local bucket, you have to split to the global bucket also. Clear? Now we will split both the global bucket as well as the first local bucket. Clear? So if you split to the global bucket, the size of the global bucket will become 3. So if the size of the global bucket is 3, then 2 to the power 3 will give you 8. Means in the global bucket, you need to store 8 entries with each entry of size 3 digit. Now we will split to that global bucket and the first local bucket to solve the collision. Now see here, I have splitted the global bucket. This is your global bucket with size 3 and these are the local bucket. Okay, and this 0 0 entries from the before table has divided into two different buckets. One will represent as 0 0 0 0 and second will represent 1 0 0. How will you know? I discussed already in that case. So 0 0 bucket has divided, means check here where 0 0 present. Clear? These are the 2 0 present, right? Then for this 2 0, what is the next digit it is associated with it? So here 0 associated and here 1 associated. Means you have two different addresses with 0 0 to represent two different buckets. I hope understood. The rest digits are not divided. That's why I simply pointed the rest of the digits into the different buckets. See here, except 0 0, 0 1 buckets, 0 1 and 1 1 bucket is representing to the last bucket. Clear? So see here 0 1 and wherever 0 1 and 0 1 and 1 1 present, so these digits are representing to the last bucket, and where 1 0 is there, that 1 0 directory is representing to the third bucket. So see here, this is 1 0 and here another 1 0. Now though the global depth is 3, hence we will consider 3 digits to store the elements inside the local bucket. Clear? Now see here, for 16, 3 LSB bits are 0 0 0, means we will store 16 here. For 4, 1 0 0, so this is 1 0 0, put 4 here. Clear? Then for 6, 1 1 0, put 6 here. Then for 22, 1 1 0, means put 22 here. Then next is 24 0 0, means put 24 here. Then next is 10 1 0 0, 1 0 0, 1 0 0 is this one, so put 10 here. Clear? Then next is 31 1 means put 31 here. Next is 7 again 1 so put 7 here. Similarly for 9 0 0 1, so put 9, this is 0 0 1. Then next is 20 1 0 0, so 1 0 0 is which one? This one, so put 20 here. Then 29 1 0 1, 1 0 1 is what? This is 1 0 1 and 1 0 1 bucket is this one, but there is no space present inside the bucket. That is in overflow condition. So though this is overflow condition, now we need to split to the bucket. Clear? So if you split to the bucket, before splitting you just check what is the size of the local bucket size and what is the size of the global bucket size. Global bucket size is 3 and this local bucket size is 2. This local bucket is also 2 because both are splitted. Then previously this bucket splitted, that's why this bucket also 2. But up to now this bucket has not splitted, that's why the size of this bucket is 1. I hope understood. The size of this bucket is 1. Means though we require to split this bucket, we need to consider only the size of this bucket. We should not consider this bucket size or this bucket size or this bucket size. Now here global bucket length equals to 3 and local bucket length equals to 1. So here 3 greater than 1. So though global bucket length is greater than from local bucket, that's why we should not split to the global bucket. we will only split to the local bucket. I hope understood. So this bucket we will split. Clear? Now let's split to that bucket. If we split to that bucket, then see the global bucket length equals to 3 only. I didn't change to the global bucket, and the size of entries are 3. Clear? Next, this last bucket is pointed by 4 addresses. I am writing here the addresses. One is 001, second is 011, third one is 101, fourth one is 111. For your understanding, I am just writing here. If you see these 4 addresses, one addresses are ended with 01 and second address is ended with 11. Clear? Just see here. This is 001 and this is 101. Clear? Here both are one type of address ended with 01, and second type of address is one is 011, second is 111. So these two are one type address. So now after splitting this bucket into 2 buckets, we will assign these 2 addresses to these 2 different buckets. So see here 111 and 011. I pointing to the last bucket, and 001 and 101 pointing to the before bucket. I hope understood. Then after doing this, we will consider the same 3 LSB bits to store the element inside the local bucket. So let's see. For 16, the LSB bits are 3 zeros. So put 16 here. Then for 4, LSB bits are 100. Put 4 here. For 6, the LSB bits are 110. See here, I am finding from this. LSB bit is 110. So put 6 here. Then for 22, LSB bit is 110. Means put 22 here. Then for 24, 3 zeros. Means put 22 here. For 10, the LSB bits are 100. So this is 100. Put 10 here. Then next is 31, 111. So 111 bucket is last one. So put 31 here. Then 7 also 111. Means put 7 also here. Then next is 001. 001 is 9. So 001. This is 001 bucket. Put 9 here. Then next is 20. The 3 bits are 100. 100 this bucket. So put 20 here. Clear? Then last is 29 and the 3 bits are 101. So check here 101. This is 101 bucket. So put 29 here. I hope understood. So with this I have completed the problem where we discussed how to overcome the collision by splitting the local bucket and global bucket. Okay. In this lecture, I discussed the concept of extendable hashing method to solve the collision in hashing technique. So I hope everybody you understood it. Thank you.